Welcome to aminacademy.com in operation research regarding mathematical formulation of LPP. Let us do some solving problems. Look at this example. The factory produces three products. These products are processed on three different machines. The time required to manufacture 1 unit of each of the three products and the daily capacity of three machines are given in the table below. Here, machine time per units, that is in minutes, machine capacity minutes per day. These are given for the machines A, B, C, and products are given 1, 2, 3. It is required to determine the daily number of units to be manufactured for each product. The profit per unit for product 1, 2, and 3 are 5, 6, and 4 respectively. It is assumed that all the amounts produced are consumed in the market. Formulate the mathematical LP model that will maximize the daily profit. We have to formulate equations LPP. Then first, look at here. First, formulation of linear programming model. Formulation of LPP, LP model. From the study of the situation, find the key decision to be made. In the given situation, key decision is to decide the extent of product 1 to 3 as extents are permitted to vary. That is, first products 1, 2, and 3. Down, assume symbols for variable quantities noticed in step 1, that is, let the extents amount of products 1, 2, 3 manufactured daily are. Next is that amount amounts amounts that decide the extent of product 1 to 3 is x1, x2, and x3. Units respect, these are x1 units, x2 units, and x3 units. Express the feasible alternative mathematical in terms of variable. Feasible alternatives are those which are physically, economically, and financially possible. In the given situation, feasible alternatives are set to the values of x1, x2, x3 are, where here noted here, x1, x1, x2, x3 are all greater than zeros. That means there's a positive amounts in the units. Now, next situation is mention the objective function quantitatively and express it is linear function of variables. In the present situation, objective is maximize the profit. That is Z equal maximize the profit is maximize the profit is given as 5 rupees, 6 rupees and 4 rupees is 5x1 plus the second profit is 6x2 and 4x3. 6x2 and 4. This is the maximizing the profit function. Now, next step is put into words the influencing the factors or constraints. This occurs generally because of the constraints or available resources or requirement demands. Express these constraints also as linear equations, that is inequalities, in the terms of variables. Therefore, we have 2x1 here, 3x1, 4x2, 3x3. 3x1, 4x2. Therefore, 3x1, 4x2, 3x1, 4x2 plus 3x3 plus 3x3 is lesser or equal to 840. Next equation is 4x1, 0x2, 2x3. 4x1, 0x2 and plus and 2x3 is 880. 2x3 is 880. Then third situation is 3x3, 5x2, 3x1 plus 5x2 plus 0x3 is lesser or equal to 830. These are the maximize the profit equation is z equal to 5x1 and 6x2 plus 4x3 and constraint equation is this one. So our situation is done in terms of equation. Look at this one more example. An investor is considering the investment scheme in security plans A and B. The risk and return associated with this security scheme is different. The scheme A gives a return of 9% and has a risk factor of 5 on a scale to 0 to 10. Scheme B gives return of 15% but has risk factor 8. The total amount to be invested in is rupees 1 lakh. 10 lakhs. Total minimum returns on the investment should be 12%. Maximum combined risk should not be more than 6. Formulate as LPP. We have to consider this situation. Look at here. Here, decision variables are X1 first is equal amount invested in scheme A. Then x2 is amount invested in scheme B, security scheme. Objective functions, that is objective functions, look at here. That is maximize equal 0.09 x1. Here the returns are, first scheme return is 9% and has risk factor 5, and second scheme is 15%. That is 0.9 x1, that is a 9% return, plus 0.015, no, this is 0.15 x2. Constraints are here x1 plus x2, that is total investment, equal to 10 lakh. Related risk, are 5x1. Look at the first scheme A have risk on 5, and second one is risk vector 8 second. 5x1 plus 8x2, which is equal is 6 into should not be more than 6, that is here 6 into 10 lakh, 6 into 10 lakh, then which is equal 5x1 plus 8x2 equal to 60 lakh. And related to risk is 5x1 plus 8x2 is 60 lakhs. Related to return, is 0.09 x1 plus 15% x2 equal 12%, that is 0.12 into 10 lakh. That means here, look at here. This the total minimum return on the investment is 12%. Therefore, here related to return is this one. That is, we can write one more time: 0.09x1 plus 0.15x2 equal here 12 zeros. We just multiply 0.12 into this. Not zero, only zero less here. Four zeros. Here, next one. Here we had to write 1,20,000 this manner. 1,20,000. These are related to return. Now, non-negativity means x1 and x2 are greater than 0. Now we'll write all in combined things like max z. Your max z is equal 0.9x1, 0.15x2, 0.09x1 plus 0.15x2 maximum, and x1 plus x2 equal to 10 lakh. Next question, your next equation is 5x1 plus 8x2 is 60,000. 5x1 plus 8x2 is 60,000. Not 60,000, your 60 lakhs. Next is related to return, that is 0.9x1 plus 0.15x2 equal 1,20,000. And non-negativities, x1, x2 are greater than 0, greater than or equal to 0. These are our LPP equations. So far we formulate LPP equation for the given problem. We have done. Please subscribe our YouTube channel.